Hi everyone. In the last two videos we have learned the concept of limits, algebra of limits and some standard result of limits that we are going to apply in the questions. Children, we have read first method as our direct substitution method. So let us see how we can do the questions which are based on direct substitution methods. Whenever the question on limits are given to you, you will always be applying first of all direct substitution method. If after applying direct substitution method, if you does not get indeterminate form, then that will be the answer. But in case if you get 0 by 0, infinity by infinity, or minus infinity or plus infinity, or 1 by 0, then you will be applying other methods. So here let's see. If I put x equal to 1 over here, then I will be getting it as minus 1 raised to power 10 plus minus 1 raised to power 5 plus 1 whole upon minus 1 minus 1. So wherever x exists, I have put x equal to minus 1. So minus 1 raised to power 10 will give me positive 1. Minus 1 raised to power odd power will give me just minus 1 plus 1, and here I will be getting it as minus 2. Minus 1 and 1 gone, so I am getting it as minus 1 by 2. So this is my answer over here. Let's see in the second question. Here it is given limit x tends to 1. So let's put x equal to 1 in the question. I will be getting it as 2 into 1 minus 1 whole square plus 5. So I will be getting it as 2 minus 1 whole square plus 5. 1 square is just 1 plus 5, which is equal to 6. So answer of this is 6. Let's see the second method, which is factorization method. That means whenever you get in the numerator or in the denominator quadratic form or cubic form, then you try to factorize it. Now I told you first approach should be the direct substitution method. If I put x equal to 2 in the denominator, then I am getting this denominator as 0. That means anything divided by 0 will be an indeterminate form. That's why I cannot apply here direct substitution method. For this question, now I will be factorizing the numerator. So I will be writing limit x tends to 2 because I have not substituted the value of x over here. That's why this will continue till we put x equal to 2. Here you know how we can solve the quadratic equation. That 3 into 10 is 30 and I want minus 1. So I will be getting it as 3x square minus 6x plus 5x minus 10 upon, this can be written as x square minus 2 whole square. Again this can be written as 3x common x minus 2 plus 5 common x minus 2. Below here I can apply x square minus y square formula, that is x plus 2 and x minus 2. Again I am writing limit x tends to 2 because I have not substituted the value of x as 2 in the question. So I will be getting it as x minus 2, 3x plus 5 whole upon x plus 2, x minus 2. Here x minus 2 gone. So I am now left with the simplified form as 3x plus 5 upon x plus 2. Now here I cannot solve it further, so I will apply, or I will put the value of x equal to 2 in the question, and I will see whether that indeterminate form has removed or not. So x equal to 2 you apply here. So 2 plus 2 is 4, which is giving me a value. So I will be just applying the value over here x equal to 2, and that will give me the final answer. So this will be 11 by 4. Let's see the next question, children. Here it is given limit x tends to root 2 x raised to power 4 minus 4 upon this. So again I can see that here I am given with quadratic equation. Alright, so I can find out the factors. But before finding the factors, first of all I will be applying my direct substitution method. Let's see, if I apply x equal to root 2 over here, then I will be getting root 2 whole square plus 3 into root 2 x is again root 2 minus 8. So I am getting over here 2 plus root 2 into 2 is 2, and this is 6 minus 8. That means I am getting my denominator as x raised to power 4 minus 4 upon 0, which is an indeterminate form. That's why I cannot apply my direct substitution method over here. So now I'll be going with my factorization method. So let's factorize it. Limit x tends to root 2. This can be written as x square whole square minus 2 whole square, and down it can be written as, this is 8. So 8 can be factorized as 4 into 2. Again 2 can be written as root 2 into root 2. Then 4 root 2 and root 2 will give me this plus 3 root 2. So I can write it as x square plus 4 root 2x minus root 2x minus 8. So I can write it as now limit x tends to root 2, x square minus 2, x square plus 2. And here I can write x common, x plus 4 root 2 minus, here again I can write minus root 2 common, so x plus 4 root 2. So here I am left with x square minus 2, x square plus 2, or I can write it as x square minus root 2 whole square, isn't so? I can again make it as a square minus b square formula. Here I am getting it as x plus 4 root 2 and x minus root 2. Now again simplifying it, I will be getting it as limit x tends to 2, x minus root 2, x plus root 2, and here I am getting it as x square plus 2 whole upon x plus 4 root 2 and x minus root 2. Again x minus root 2 and x minus root 2 gone. Now I can apply x equal to 2 over here. So here I am getting some value in the denominator. That means my indeterminate form has been removed from here. Now put x equal to 2 here. You will get it as 2 plus root 2, and here you will get under root 2 whole square, which will just give me 2. So 2 plus 2 is 4 whole upon 2 plus 4 under root 2. Now rationalize it further. I'm so sorry, here it was root 2, root 2, root 2. So I am putting x equal to root 2. So here I will be getting it as root 2, and here also I will be getting it as under root 2. Now you can see root 2 plus 2 root 2 will be just 2 under root 2, which will make it 8 under root 2 whole upon, this will be 5 under root 2, under root 2 under root gone. So you will just get 8 by 5 as your answer. Have a look. Let's see the next method, which is rationalization method. This method is applied when we get the question in root form. Let's see. I told you whenever you get a question of limits, then you always try direct substitution method first. So if I put x equal to 0, I'll be getting it as indeterminate form. Then I will be looking for my factorization method, since the terms are in root, so I cannot factorize them easily. So here I'll be adopting rationalization method, and it says you multiply and divide with the same term but with the opposite sign. That means I am writing it as it is and I am multiplying and dividing by this root term. So I can write it as 1 plus x square. This is minus, so opposite sign we will be taking under root 1 plus x upon under root 1 plus x square plus under root 1 plus x. Multiply them, limit x tends to 0. So this is a minus b and a plus b form. So I can write it as a square minus b square whole upon x into, I can write 1 plus x square plus 1 plus x as it is. Now open this, I'll be getting it as limit x tends to 0, square will get cancelled with this under root sign. So I'll be getting just 1 plus x square minus, and this will be 1 minus x. But since minus sign is outside, So I'll be writing it as 1 plus x upon x under root 1 plus x square plus under root 1 minus x. Now 1 and 1 gone. So I am getting my question now as x square, this is x tends to 0, plus x whole upon x under root 1 plus x square plus under root 1 minus x as it is. Now let's see, have I removed my indeterminate form or not? If I put x equal to 0 over here, again I am getting it as indeterminate form. But I can see that this x can be cancelled if I take common from numerator. So let's take common from numerator. So my aim here is to remove this x somehow. So I'll take x common from the numerator and then I can remove this x which is giving me an indeterminate form. So just remove it and now you put x equal to 0. So if I put x equal to 0 over here, I'll be getting it as 1 upon. Here I'll be getting it as 1 plus 1. So under root 2 plus this will be 1 minus 0 will give me just under root 1 which is 1. Now x equal to 0 will give you just 1. 1 plus 0. Alright. Now you are getting it as 1 upon under root 1. Under root 1 can again be written as 1. So your answer will be then 1 upon 2. So it is 1 by 2. Root 1 is 1. So 1 plus 1 is 2. Now let's see the next one. Using the formula limit x tends to a, x raised to power n minus a raised to power n whole upon x minus a will give you n into a raised to power n minus 1. This formula can only be applied if the constant term used here is the limit of the variable. Now you look here. First of all, we'll compare the formulae and the question. Here the formula is given to me this, and let's see whether the given question in the standard form is in the standard form or not. So here I am getting x raised to power n minus 1. 1 can be written as 1 raised to power n. Alright. So here it is given x minus a. X minus a means I should be having x minus 1 in the denominator, which is missing. And in place of that it is given x raised to power 10 minus 1. So what we can do, we can reframe the question into this standard formula form. Now, first of all, I told you whenever your question in limit is given to you, always use the direct substitution method. So if I put x equal to 1 over here, I am getting it as an indeterminate form. So I will not be applying that method. Again, I cannot factorize it also. So I can see this should be done by this formula. So let's see how I am going to do this question. This can be written as limit x tends to 1. This is x raised to power 15 minus 1 raised to power 15. I can write it as, since here the power are same, that's why I have written raised to power 15. But here in denominator, I should be having x minus 1, which is not there. So what I will be doing, I will be multiplying and dividing with this term because I need this term. So I am multiplying and dividing. Alright. Now what about this? I will be writing this as x raised to power 10 minus 1. Alright. Minus 10 minus 1 raised to power 10. Now this formula can also be applied here if I get in the denominator x minus 1. And we know from our previous knowledge, this x minus 1 can also be taken down in the denominator of this term. So I can write it like this: limit x tends to 1, x raised to power 15 minus 1 raised to power 15, x minus 1 into 1 upon limit. Here I am using algebra of limits. X tends to 1, that means this limit can be given to this also and to the next term also. X raised to power 10 minus 1 raised to power 10, and this x minus 1 term can be written here. So again you can say this is your n, which is 15. Now I am applying this formula, n which is 15 into a, which is 1 raised to power 15 minus 1. Alright. And here again I can write this complete term as n, which is 10 into a is 1 raised to power 10 minus 1. So I'll be getting it as 15 into 1 into 1 by 10 into 1. That means I'll be getting 15 by 10, which is 5 3s and 5 2s. So 3 by 2 is my answer. Let's see the next question. Here it is given x cube plus 27. But here in the formula, I am getting negative. So I'll be converting this into negative form, which is limit x tends to minus 3. Because if you'll apply direct x equal to minus 3, then you will be getting your denominator as 0, which is indeterminate form. Alright. So I am applying this method now. X cube minus, this can be written as minus 3 raised to power 3. Isn't that? Whole upon x raised to power 5 minus I can write it as 3 raised to power 5. Okay. Now to get this form, I need x minus 3 in the denominator, which is missing. So I can write here limit x tends to minus 3, x cube minus 3 whole cube upon x minus 3 into x minus 3, multiplying and dividing by the same term. And here I am getting it as, I can write into, this is 1 upon limit x tends to minus 3. Here I can write x raised to power 5 minus 3 raised to power 5. Again this can be taken down. So question becomes limit x tends to minus 3, x cube minus 3 whole cube x minus 3 into 1 by limit x tends to minus 3, x raised to power 5 minus 3 raised to power 5, and this x minus 3 can be taken down. Now this has become our standard formula. So here I can just write it as n is what? Minus 3 into, plus 3, n is your 3. So I can write it as 3 into a is minus 3 raised to power n minus 1, alright, into 1 upon, here it is, n is 5 into a is minus 3 raised to power 5 minus 1. So here it is 2 minus 1. So minus 3 whole square will give me just 9 into 1 upon 5 into, here minus 3 raised to power 4 will give me 9 into 9, I can write. So 9 and 9 gone, 3 ones are. So I am getting my answer as 1 by 50. Have a look. In this video, I have taken all the methods which are involved in solving the algebraic limits. Now in the next video, we will be taking the questions which are not in algebraic limits. That means the trigonometric, exponential and logarithmic functions. We will be taking the questions in the next video. Till then, you revise these methods.